Right, so I'm just going to quickly show you exactly what you're going to get out of this. Here it is. It is super simple. Really, it takes all the kind of principles that the Epic example does in their content examples on the render to target map, I believe. So it really is kind of just stolen directly from them and applying this kind of neat little material on top. That will just draw out a material for you to use, and you can just right click, asset actions and export. Okay, so let's get going. Using the third person template, so you can just follow along really easily, and all you're going to need is some kind of 3D package like Maya or Blender to export a really simple plane. So let's get going. Let's first start off by making our folders. Let's just call this heat map, and we're going to need a models, a renders, blueprints, and one last one that I can't remember. Is it materials? Of course it is. Just a minor blank then. Okay, so first things first, let's get the model out of the way. So the model is this really simple plane, but there's a few key things you need to keep in mind. First, that your Maya or Blender is set up to the Unreal Engine units. You can do that by doing a quick Google, literally just like set up Maya for UE4. And in mine I've got Z set up here. You can do that in the FBX export options, but I've opted to just have it permanent. Okay, so the important things to also note is that the plane itself, its width and height are going to have to be set to the exact width and height that you intend to use in game. So for this I'm using 1024 just as an example, and the subdivisions can be whatever you like. If you want to perform any kind of like tessellation, like moving of the vertices at all, you're going to want like a load more subdivisions. I know I use it for, I use this exact method for snow, so and that's actually using a landscape, but the actual resolution of that is way higher. So this also needs to be set at minus the height, minus the width rather in the Y, and plus the height in the X, putting the bottom left corner at 0, 0, 0, and then once you're done with all that, you can just export it all out to your working directory. So I'm just going to call this example plane for now. That'll do. And we'll jump back in here and import it. So, okay. We don't actually need this material, but I'll leave it there for now. Let's get going on a brand new map as well. And we should, yeah, we have our player already set up. So we don't need that. And let's make our blueprint. I'm just going to call it BP heat map. And import stack mesh, example plane. Save it. Oh, let's save the map out as map tutorial. Let's just import this in. So it doesn't matter where this plane goes as long as the player can collide with it. And if you're not exporting any collision with it, we can generate the collision by using simple add box collision, and that should do the trick for us. Yep. Also, if you've got something more complicated and you haven't gone and made your custom collision yet, you can always turn on use complex collision is simple. It's not recommended though, however, because it's super costly. Okay, so next let's get our material made for the kind of splat that draws directly to a render target. And I'm going to call it heat splat. Let's just make that S capital. And now I'm just opening up my other material from my other project so that I can cheat. Right. Okay. So first off, we're going to need a vector 3, and I'm getting that, by the way, by holding down 3 and left clicking. So that's just a really quick way of creating a vector. Let's convert it to a parameter and call it force, or well, let's just call it position. Instead of completely ripping off the name types from the example project, which uses forces, we'll kind of just keep it simple. So make a parameter, call it position. This is going to take the X and Y position of the player character and map it to that plane. And we're going to get that by using a component mask for red and green, because the X and Y is only going to be plugged into these two, and we're not going to need the blue or the alpha channel. Next, we're going to need a texture coordinate, and then subtract. And I'll explain all this in a minute. And next, a vector length. Literally just outputting the length of that as a float. And we're going to 1 minus it. And subtract. And now I'm holding down 1 and left clicking and creating a parameter for our size. So this is going to help us just really quickly find out what kind of size we want to be drawing to that render target. And another 1 minus. And now we just want to plug these together. Okay, straighten it all up. And finally, we're going to want to hold down M and left click for a multiply, hold down 1, left click again for another constant, convert this to a parameter for strength. So this is, as it says, literally just going to be an easy way for us to decide how much strength of a splat we want to be kind of like drawing to that render target. Okay, and just plug that into the emissive color. Make sure these are set to 1 at default, just so that we can see. Okay, so let me just go over this really quickly to the best of my ability. So the position is going to take in the X and Y of the character kind of local to the plane that we just created. But at the moment, as we're using these texture coordinates and subtracting, we're kind of just locally finding out where this kind of splat is. And if I just show you for an example, I just shove this right over to the far side. So 0 to 1 being across the top here, and then 1 down here on the Y. So now it's in the bottom corner. So you can already see how that's kind of like relative to the texture coordinates, just placing this kind of dot, and then let's make it small. Too small apparently. To this example plane in your kind of material preview here. And that is it for the material for the splat. Let's apply and save. Okay, so next we're going to want to bring up our heat map blueprint. And excuse me again while I cheat once more and open the blueprint for my already done project. Okay, so we're going to want to create our custom event that draws directly to the render target. So let's just call this draw to render target, creatively enough. Okay, And now we're going to need a few variables. First off, we're going to need a render target. Let's call this render target runtime of type render target. Render target 2D. Yep. Let's make it public. And then we're going to need just a resolution float. So this is going to be the size of your plane, and in our case we start off at 1024. We can make this public as well, so we can just change it as we like. Okay, so next let's create our dynamic material. So create dynamic material instance, and this is going to be of the type heat splat. So this is just so that we can change the location and size and strength at runtime, and I'm going to assume that most people have already encountered things like dynamic materials before, so I'm not going to go through the whole principles of them. And let's just promote it to a variable and call it MID for material instance ID heat splat. Okay, so compile, save that. Let's take our dynamic material instance and set scalar parameter value. Let's also give this to 3 actually, if I can hit the new parameter button. 3 new inputs, one of type vector for the location of the player being put in, one of a float for the strength, and another float for the size. So this is going to be size, and we're just going to copy and paste that. Strength, let's just drag this up here. And finally our location by set vector parameter value. So I'm going over this fairly quickly because honestly you are more than likely to have seen a few tutorials by now that have gone through setting parameters in dynamic materials. If you're looking to create something like a heat map, I really do imagine you've already been over that kind of stuff before. So let's hook this up. Hook the strength and the size up. And now for the last bit, which becomes a little bit more complicated, and this is as complicated as this tutorial gets really. We're going to take our plane, and I'm just going to call it something like data gathering plane, or rather position gathering plane instead of data, so we exactly know what it's doing. Compile and save it. Okay, so let's get a reference to it and get its world transform. We're going to invert its transform, and now we're going to transform this location to that of the inverted planes. So all of this is in the content examples, and I really am just stealing it. So Epic is whoever made that at Epic is the real genius. So we're going to divide this by, no, not a vector, but by a float, and it's going to be the resolution. And now just drag this into the color, and it will automatically convert it to a linear color for you. And now we need to call this position, so it knows. And I know I said finally before, but this really is finally. Draw material to render target. So we're going to draw our dynamic heat splat material to a render target that we've not created yet. Okay, so in your renders folder, let's go and create a render target. And I'm going to call this heat map. No, I'm going to call this render target underscore heat map runtime. So this is what's going to be drawn literally at runtime, and we're going to set the X and Y to 1024. We're going to clamp it so that if our player gets to the one side of the plane, like I don't know, maybe this side, it's not going to accidentally bleed across onto the other side. Let's just say for now no MIPS and compress without alpha, and I'm pretty sure that is all we're going to need to do. Okay, so it doesn't need to be 1024. You can you do a size of your choice, but make sure that all the values do correspond. Okay, so let's finally put in our render target runtime into there, but this does need to be set as a default. And again, you can set the resolution and render target in here like access via these public variables, just to make it a little bit more easy for you if you wanted to create a few of these, save them all out, or if you decided to make a few of these in various different locations in your game. It's just quite simple to drag in a new one like so. Okay, so that's the fairly complicated part out of the way. Next, we're going to need to be able to tell this event here, let's delete these, where the player actually is relative to the plane. So we could now just grab the player characters X and Y from the world straight away, but I'm going to go a slightly more complicated route, and it is more costly, but really I think it's worth it, where we're going to do a multi line trace from the plane to the player, so that way we can kind of create custom bounds if we needed to exclude locations from the heat map, rather than always finding the position of the player in the... I'm going to be really bad and do this straight from the tick. And let's just bring in the begin play. So yes, I realise I did just delete both of those. Okay, so let's get player character, and we're going to make a reference to him. So player ref. If this is like a multiplayer game, which I mean is probably really useful to have a heat map for a multiplayer game map, so that you can really tell the flow of where everybody's kind of going in your level design. This is going to get a little bit more complicated for you, where you're going to need to be able to get every player and loop through them all. But this custom event here, if you call it however many times you like, it will always draw to the render target. It doesn't need to be just called once, so you could call it for every player, every tick, and it will continue to draw loads of kind of like different dots wherever each player is. Okay, so now we've got our player reference. We're just going to first check if it's valid, if I can spell it right. Okay, and now we're going to do a multi-line trace for objects, and let's make an array for our object types, both world static and world dynamic. Okay, so we're going to get the actor location, and this is going to be the start of our line trace, and the end is going to be this actor's, well, just in case this plane isn't zeroed out, we'll get the world position of the plane. We'll get the world location of the plane, we'll split this, and we'll break this, and we'll make a whole new vector. Let's just clear the way a little bit. So here I'm just grabbing the X and Y of the player and getting the Z of the actual plane that we want. However, I'm just going to minus 1 from it. It's already set to 1. So that we know it's not going to be just kind of the line isn't going to just like trace straight down and just kind of just hover just above it. We're going to just minus 1 to make sure that it does clip through and create a kind of like a hit block. So yeah, I'm doing it this way so that we can always get a line trace directly from the player position to the Z of the plane, instead of kind of like maybe getting the location of the player and timesing that by a minus 1 in the Z vector and then just doing that down by, I don't know, like 1,000 units. This way we will always be line tracing all the way down to the plane. And I'm doing a multi-line trace because as you kind of traverse around your level, you're going to probably encounter lots of different obstacles and stuff, and you're not always going to hit that plane. And this plane is probably not going to be your collision kind of floor anyway. You might have a landscape above it, and you've just popped this plane underneath to gather this data. So let's plug this in, and we're going to, for each on the hits, and break. So we're only going to make this check if it is both a blocking hit and if the hit actor is equal to the, what am I doing? To self, to this actual actor itself. And always make sure that if you're doing something like checking to see if it hits itself, you don't have ignore self checked. That caught me out a little earlier. We'll just do a 4:1 frame debug for now. Check all these, absolutely fine. So trace complex you might want on if, like I mentioned before, you've got collision complexity set to use getting tongue tied. Use complex collision is simple. You're going to want to have that trace complex ticked. Okay, so all our checks, if they're clear, we're going to want that, whatever it's called, draw to render target. Event being called here, and we're going to grab the location of the hit and give it kind of just a starting value of 1, and the size is going to be pretty big if it's 1, so let's set it to like 0.01 instead for now, and we'll see what that kind of like churns out. Okay, so I think that should be it for now. Let's bring up our little render target here and just have it over the screen as we test out to see. Okay, so first off, we're not seeing anything be drawn to it. Let's close it out and open it up again. So here we go, we've got a dot. So let's do it again. Let's give it a little bit more time just in this one space. I'll walk around. Okay, yeah. So as you can see, I've missed out one key thing from the previous material, and I'm glad I did because it's a perfect example to show you. I did it completely intentionally, I swear. Okay, so as you can see, it's just the dot running around, and it's not actually kind of creating a trail. That's because it's not adding to the render target. And this is key for the heat map, and why that content examples is so perfect, and why I could kind of just, like, I guess, reverse engineer it to use as a heat map as the way I did, is because the type, the blend mode, is set to additive. And let's apply and save. And let's bring up this render target again. Play it out. Okay, so as you can see, we started drawing because it is literally set to additive. So what's happening is every tick, the line trace is coming down and hitting the plane and kind of getting that location, and then we're getting the local location of the plane and drawing that to this render target. And the additive is going to let us kind of keep on drawing every tick, and it's going to push the limits from far beyond that 0 to 1 range that we can actually visibly see as white and black here. But we're probably getting massive values here, so we can really kind of like use that to our advantage, and these lower values here to our advantage as well. So we're going from, because it's grayscale, we're going from like 0 to, I don't know, maybe 10 or some, probably considerably higher, like on these really dark patches. And we can use that as a alpha to lerp between various colours. And that's exactly what we're going to do. So we're going to make a new material now for our floor, and just let's call it heat map bake, for example. And the heat map bake is going to take a texture, and I'm getting this by holding down T and left clicking, and it's the runtime, render target heat map runtime. And I'm going to cheat once more again and open up the material I've already made on the other screen. So we're going to use this as our kind of alpha. We're going to need a multiple lerp. So just type in lerp, and we're going to need a multiple lerp float 3. So let's hold down 3 and click 4 times. And let's put in the colours that we want to use for our heat map. So I have literally used colours that I've seen on the internet. Just had a quick look, and it looks to go from red to yellow to green to this light blue to dark blue. And again, we're seeing the same kind of thing when you just do a simple Google image search for heat map. So that's exactly what I'm going to do. I don't pretend to know exactly anything about heat maps really, but I'm just going off what I've seen. So let's make a solid blue, a solid green, a solid yellow, and finally a solid red. Let's plug these into 1, 2, 3 and 4. And we're going to grab the red channel because the alpha just takes a float. This actually, I'll show you now, the render target, which is in our renders. It's actually been drawn to all 3 channels, and I've not figured it out yet, but I'm sure there's a way to do it to draw to just one of these, because it really is kind of a waste. You could just, because we're only going to be using the red channel, but you could store various different maps in the other respective channels. But for now, we're just going to use red and leave these as wasted. So the alpha is going to go from 0 to 1. So 0 being blue, 1 being red, and it's going to go through all of these relative to the grayscale here. And let's just plug this straight into the emissive with the 4 inputs. And straight away, there we go. So let's edit our blueprint. And for the purposes of just demoing, let's pop in our heat map bake material. And we're going to need to save and apply it here. And there we go. We have our heat map being drawn by the player, and that is pretty much it. It looks like we could do with making the size a bit bigger. Let's do that by adjusting it in here. Let's make it 3 times as big. go. So that's a little bit more visible. Oh, and here is something quickly to just go over, because as you can see, every time I run it, we're getting the same map again and again, and you obviously don't want that. As you bring on a new player, you're going to want to have a completely new map, and then you're going to export it and clear it out again. And you can do that really easily by just changing your value in here, and then changing it back. That will clear it out, but that's really quite bad. So instead, let's go to our blueprint, and at the start of every play we're going to want to grab our render targets, hold down control and let go, and it just gets the reference to it, by the way, and then clear render target 2D. Oh, and it's taken in that instead. Let's do it again. Clear render target 2D, get rid of this, plug it in, and the clear color is just going to be black. So at the beginning of every play, we're just going to be clearing this out. So here we go, and exit, and then play again, and there we go, it's completely wiped it. Okay, so next thing is we're going to want to be able to grab a export of this for reference in some kind of external thing, and then you can bring it into Photoshop or whatever you like. So instead of just getting this kind of, let's get a better example, instead of getting this grey scale, we're going to want the actual colours. And to get that, we're going to make another render target. I'm just going to, for the sake of it, duplicate this one and call it render target heat map bake. Back over to our blueprint, and now on end play, so when we finish, I'm going to do something that we've already done before, which is draw material to render target, copy and paste it. And I'm going to use the bake, but actually let's make it a quick render target. Let's make it a quick public variable, again for ease of use. And I'm going to grab the material, what's it called, heat map bake. So now, at the end of every play, this is going to have the coloured heat map. There we go. At the end of play, it draws to it, and there you go. And then all you need to do is right click, asset actions, and export it. And there we go. That is how you make it. And I'm just going to quickly demo while I'm here that I'm pretty sure this player character can drum it, can't he? Yeah. That no matter how many kind of obstacles you have with that kind of multi-line trace, it will draw straight through them. So I've got, say I've got a whole level above this render target, and I'm walking around on all these obstacles, it's still going to draw straight down onto my render target, or plane, or whatever you want to call it. There we go. Hope you enjoyed the tutorial, and that is all.